In my previous lecture, I have explained introduction to hierarchical clustering and different type of distance measures. In this lecture, I have taken a numerical example. With the help of the numerical example, I am going to explain how to do hierarchical clustering method. For that same problem, I am going to explain how to use Python for doing hierarchical clustering. So, the agenda for this lecture is agglomerative hierarchical algorithm. The second one is Python demo. So, the example of hierarchical agglomerative clustering HAC. A data set consisting of 7 objects for which 2 variables were measured. There are 7 objects 1, 2, 3, 4, 5, 6, 7, variable 1 and variable 2. So, variable 1 is 2, 5, 5.5, 5 and so on, variable 2 is 2, 4, 5, 2, 1, 6, 5, 6 and so on. When you plot in the scatter plot, it is appearing that there are 7 data set, variable 1 in x axis, variable 2 in y axis. Now, we are going to do hierarchical clustering for this data set. What is the first one? Calculate the Euclidean distance and create a distance matrix. So, what we are going to do? First, we are going to create a distance matrix. For that, we are going to find out the distance between 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7 and 2 and 3, 2 and 4, 2 and 5, 2 and 6 and 2 and 7. Then 3 and 4, 3 and 5, 3 and 6 and 3 and 7. Then 4 and 5, 4 and 6 and 4 and 7. Then 5 and 6 and 5 and 7. Finally 6 and 7. First we will find the distance between object 1 and 2. So, the object 1 is 2 comma 2, object 2 is 5.5 comma 4. After finding the Euclidean distance, we know the formula is x2 minus x1 whole square plus y2 minus y1 whole square. So, 5.5 minus 2 whole square plus 4 minus 2 whole square, that is your 4.02. Then let us find the distance between, now we have seen 1 and 2, now the distance between 1 and 3. So, 1 and 3 is, the position of 1 is 2 comma 2, position of 3 is 5 comma 5. So, it is 5 comma 2 whole square plus 5 comma 2 whole square. So, it is 4.24. Now, let us find the distance between 1 and 4. So, this 1 and 4. So, 2 comma 2 and 1.5 comma 2.5. So, the distance is 1.5 minus 2 whole square plus 2.5 minus 2 whole square, that is 0.71. Now, we will find the distance between 1 and 5. So, this 1 and 5, because this we have done it. So, 1 and 5 is 2 comma 2, the position of the fifth object is 1 comma 1. So, it is 1 minus 2 whole square plus 1 minus 2 whole square, it is 1.41. Now, we will find the distance 1 and 6, that is 2 comma 2, then 7 comma 5. So, it is 7 minus 2 whole square plus 5 minus 2 whole square, that is 5.83. Similarly, we can find the distance between 1 and 7, that is 2 comma 2 versus 5.75 and 6.5. So, it is 5.75 minus 2 whole square plus 6.5 minus 2 whole square, we got 5.86. Now, we have done 1 versus all the point. Now, we go second versus 3, the distance between 2 and 3. The position of 2 is 5 comma 5 comma 4, 3 is 5 comma 5. So, the distance is 5 minus 5.5 whole square plus 5 minus 4 whole square, that is 1.12. Now, 2 and 4, 5.5 comma 4 is the position of 2, the position of object 4 is 1.5 comma 2.5. So, the distance is 1.5 minus 5.5 whole square plus 2.5 minus 4 whole square, that is 4.27. Next we will find the distance between 2 and 5. We know the position of 2 is 5.5 comma 4, the position of object 5 is 1 comma 1, see this point. So, the distance is 1 minus 5.5 whole square plus 1 minus 4 whole square, that is 5.41. Now, we can find the distance between 2 and 6. So, the position of object 6 is 7 comma 5. So, the distance is 7 minus 5.5 whole square minus 5 minus 4 whole square, that is 1.81. The next one, we are going to find the distance between 2 and 7. So, 2 and 7. So, the position of object 7 is 5.75 comma 6.5. So, the distance is 5.75 minus 5.5 whole square plus 6.5 minus 4 whole square. So, this difference whole square and this difference whole square, that is 2.51. Now, the point 2, the object 2 and other all 7s we compare. Now, we will compare 3 and 4, 3 and 5, 3 and 6 and 3 and 7. So, the 3 and 4 distance is, the position of point 3 is 5 comma 5 and 4 is 1.5 comma 2.5. So, this distance versus this distance, this difference. So, 1.5 minus 5 whole square plus 2.5 minus 5 whole square, that is 4.30. Next 3 and 5. So, 5 comma 5 and the 1 comma 1 is position of object 5. So, what will happen, 1 minus 5 whole square plus 1 minus 5 whole square, 5.66. Now, 3 and 6. So, 3 is 5 comma 5, 6 is 7 comma 5. So, the difference is 7 minus 5 whole square plus 5 minus 5 whole square, the distance is 2. Now, we are going to find the next one, 3 comma 7. So, 3 comma 7, what is the distance? We know position of 3 is 5 comma 5, 7 is 5.75 minus 6.50. So, this difference whole square versus this difference whole square. So, 5.75 minus 5 whole square plus 6.5 minus 5 whole square, that is 1.68. Now, we have find out 3 versus all the point. Now, we will take 4 comma 5 and 4 comma 6 and 4 comma 7. So, the distance between 4 and 5 is 1.5 minus 2.5 is the position of object 4. For the fifth one, it is 1 comma 1. When you look at the distance, it is 1.58. Then 4 and 6, we have done that one. Now, we will go for 4 and 6. The 4 and 6 is the fourth 1.5 minus 2.5. The sixth position is 7 comma 5. So, the difference is 7 minus 1.5 whole square plus 5 minus 2.5 whole square equal to 6.04. Now, we will find out 4 versus 7, the distance between 4 and 7. The 1.5 comma 2.5, the position of object 7 is 5.75 minus 6.50. So, this difference whole square plus this difference whole square. So, 5.75 minus 1.5 whole square plus 6.5 minus 2.5 whole square, that is 5.84. 5 we completed. Now, we will go 5 and 6 and 5 and 7. So, the distance between 5 and 6 is 1 comma 1 is the position of object 5. For 6th one, it is 7 comma 5. So, it is 7 minus 1 whole square plus 5 minus 1 whole square, that is 7.21. Now, we will find out distance between 5 and 7, that is 1 comma 1 versus 5.75 minus 6.5. So, it is 5.75 minus 1 whole square plus 6.5 minus 1 whole square, 7.27. Now, 6 versus 7, we will find out the distance. So, that is position of object 6 is 7 comma 5, position of object 7 is 5.75 comma 6.5. So, the distance is 5.75 minus 7 whole square plus 6.5 minus 5.00 whole square, that is 1.95. Now we have compiled all the distance. As I told you, this is the distance matrix. See that this diagonal will be 0 because the distance is 0. We got the distance between 2 and 1, 3 and 1, 4 and 1, 5 and 1, 6 and 1, 7 and 1. This value which we got from our previous slides. So we got the distance matrix. After the distance matrix, for that hierarchical agglomerative method, select minimum element to build the first cluster formation. So among this, find out where there is a minimum distance. So the minimum distance is this one, 0.7. What are the two objects between 4 and 1? So what is going to do? We are going to form a cluster. In that there are two elements is going to be there, 4 and 1. So the 4 and 1 will form a cluster. So we got this one, 4 and 1. This is our first cluster. We are going to find the distance between that cluster 1, 4 formed a distance versus 2. So what we are going to do? We are going to find out distance between 1 and 2 and 4 and 2. Whichever is minimum, we are going to take that distance, because in cluster 1 already there are two objects there. We are going to consider the minimum distance. So the distance between 1, 2, see that this value 4 and 4, 2 is 4.3. This value we take from the table. So the minimum distance is 4. The next one, 1, 4 versus 3. Similarly 1, 4 versus 5, 1, 4 versus 6, 1, 4 versus 7. So if you want to know this cluster versus 3, so minimum distance between 1, 3 and 4, 3, this 1, 3 and 4, 3. So 1, 3 it is a 4.2, 4, 3 it is a 4.3, this value. So minimum is 4.2. Now fourth we cannot go, already the fourth one is already gone to that cluster. So we will go to fifth. So 1, 4 versus fifth object. For that we have to find the minimum distance between 1, 5 and 4, 5. So 1, 5 is 1.4, this value, and 4, 5 is over this value 1.6, that 1.6, the minimum is 1.4. Then 1, 4 with 6. Now what happened here? We have to find out the minimum distance between 1, 6 and 4, 6. So 1, 6, so 1, 6 is 5.8, this value, and 4, 6, that is 6, this value. So minimum is 5.8. Now why we are taking 1.4? Because this we formed one cluster. So from this cluster there are 2 object 1 and 4. From 1 and 4 the 7 is how far away? So two way we have to do, 1 and 7 we have to find the distance, and 4 and 7 we have to find the distance, whichever minimum that has to be kept. So 1 and 7, 4 and 7. So 1 and 7 is this one 5.9, 4 and 7 that is your 5.8. So minimum value is 4.8. Now we are going to update this value. So what update we have done that one? Since 1 and 4 form a new cluster, so now we find this value. How we got this value? So 2, 1, 4. So 2, 1, 4 is 4. So we updated. Now so updated the distance. This distance matrix is going to be used for our further steps. So now in that updated matrix again you find out which is minimum. So this 1.1 is minimum, that forms 3 and 2. So now what is happening? The 3 and 2 is going to form one cluster. Yeah, 3 and 2 is formed one cluster. Now since 2 and 3 is formed a distance and already there is one cluster 1, 4. So we are going to find out the distance between 2 and 1, 4 and 3 and 1, 4. So 2 and 1 comma 4, you can find out this is 4 because 1 and 4 formed a cluster. Then 3 and 1 comma 4, 3 and 1 comma 4 is 4.2. In this minimum is 4. Similarly, the distance between this newly formed cluster 2 comma 3 versus 5, fifth point. We are not going to fourth one because 4 is already formed a cluster. So the fifth one, so we have to find out the minimum distance of 2 comma 5 versus 3 comma 5. So in 2 comma 5 the distance is 5.4, this value. 3 comma 5 5.7. So we got this value. Between 5.4 and 5.7 minimum is 5.4. Now 2 comma 3 versus 6. Now we have to find out the distance between 2 comma 6 and 3 comma 6. So 2 comma 6, where is 2 comma 6? 6 comma 2, this is 1.8, this value, and 3 comma 6, 6 comma 3, see this 2 value. So in that minimum is 1.8. Now the last point is 2 comma 3 versus 7. So what we have to do? We have to find the minimum distance 2 and 7 and 3 and 7. So between 2 and 7 minimum distance is 2.5, 3 and 7 minimum distance is 1.7. So the out of this minimum is 1.7. Now we are going to update this new distance. So this was updated distance, but you see that 2 and 3 is formed one cluster. Previously 1 and 4 one formed a cluster. Now the next slides, what we are going to do among these new updated distance matrix, which is the lowest value. So select the minimum element to build the next cluster formation. In that the minimum point is this 1.4. So what is going to happen? This object 5 is going to join with this cluster 1 comma 4. You see that the object 5 is going to form with cluster 1 comma 4. Now what we are going to do? You see that already this is a new cluster. Not new cluster, already 1 comma 4 is there, one cluster. In that again the object 5 is added. So the distance between this cluster versus another cluster, in that there are 2 objects 2 comma 3. So what we have to do? Minimum distance between 1 and 4 and 2 comma 3 and 5 and 2 comma 3. So what is happening here? 1 and 4 is there, 2 comma 3 is there, the distance is 4. This value we got it. The distance between 5 comma 2 comma 3. So this is 5.4. So this value we got it here. This value got it. The distance minimum is 4. Similarly, minimum distance between 1 comma 4 comma 5 versus 6. So what you have to do? 1 comma 4 versus 6, 1 comma 4 versus 6 and 5 and 6. So 1 comma 4 versus 6, 1 comma 4 and 6, this is 5.8, right. So this value got here. So 5 comma 6, 7.2, we got this value here. The minimum is 5.8. Now there is a 7th object is there. Let us see how far away the object 7. So what we have to do? We have to find the minimum distance 1 comma 4 and 7, 1 comma 4 and 7 and 5 comma 7. So the distance between 1 comma 4 and 7 is 5.8. So this value, and 5 comma 7 is our 7.3. So the minimum is 5.8. Again we will update our distance matrix. So what happened now? You see that the 5 has entered into this cluster because already there is 1 comma 4 is there. So this is our updated distance matrix. The next step, what we are going to do? In the updated distance matrix, look at where there is a minimum distance is there. So the 1.7 is the minimum distance. So what is going to do that one? The object 7 is going to add into the cluster 2 comma 3. So now we will update this distance. Yeah, what happened? See that the 7 is going to form in that cluster. Now what happened? We are going to, you see that already there is a cluster, in that 2 object is there because 7 also joined there. So the distance between this cluster versus 1 comma 4 comma 5, this is another cluster. So, what we are going to do? So, 2 comma 3 comma 1 comma 4 comma 5 and 7 comma 1 comma 4 comma 5. So, 2 comma 3 this one, 2 comma 3 1.45, yes, the distance is 2 comma 3 1.45, this distance, this 4 has come here. Second one, the distance between 7 comma 1 comma 4 comma 5. So, this one 5.8. So, this distance has come here. Out of this, minimum is 4. Now, this newly formed cluster versus 6. So, here one point is 2 comma 3 versus 6 and 7 comma 6. So, 2 3 versus 6, what is the distance? 2 3 versus 6, this is 1.8. So, that distance came here. So, between 7 and 6 the distance is 2. So, that distance has come here. Now, the minimum is 1.8. We cannot go next one because 7 has already gone into that cluster. Now, again we will update that. Now, in the updation you see that we have formed 2 clusters, in that 1 comma 4 comma 5 is one group, 2 comma 3 comma 7 is another group. This is updated distance matrix. This value 4 we got from here, this 1.8 we got from here. Now, the next stage, select minimum element to build the next cluster formation. So, out of this the minimum value is 1.8. This gives the minimum distances between 6 and the cluster 2 comma 3 comma 7. So, what is going to do now? The 7 is going to join with this cluster where 2 3 7 is there. See that it has gone to 2 3 7. Now, recalculate the distance to update the distance matrix. So, the distance between 2 comma 3 comma 7 comma 6 versus 1 comma 4 comma 5. So, what you have to do, the distance is 237 versus 1.45, you have to find out this distance. So, 237 1.45, this distance, the minimum distance, that one we brought it here. The next one 6 comma 1 comma 4.5. So, 6 comma 1.45, that is a 5.8. So, in that the minimum distance is 4. This is our updated matrix. Now, what happened? In that the minimum value is 4. So, what happened? This 2 comma 3 comma 7 comma 6 will join with 1 comma 4 comma 5. So, that is nothing but the everything is joined together. Now, let us see how to do this agglomerative hierarchical clustering method with the help of Python. So, we have imported the data, import numpy is np, import pandas as pd, import matplotlib.pyplot as plt, import scipy. From scipy.cluster.hierarchy import fcluster. From scipy.cluster.hierarchy import cophenet, copenet. From scipy.spatial.distance import pdist. So, I have data in hierarchical clustering. So, what happened? This was our data set. For this data set, we have plotted the 2-dimensional picture. So, in that all the objects are displayed. Now, when you run this command, that is from scipy.cluster.hierarchy import dendrogram comma linkage, you will get this kind of pictures. So, what is happening? You see that this is the way 1 and 4 are joining together at this stage. After that, along with 1 and 4, the 5 is joined. Initially 2 and 4, 2 and 3 are joined. So, along with 2 and 3, 7 is joined. After some time, along with the 7 comma 2 comma 3, 6 also joined. At the end, see that the blue line which says all are forming one clustering. This picture shows the dendrogram. So, for that, from scipy.cluster.hierarchy import dendrogram comma linkage. So, linked equal to linkage data comma single, we are going to have a single linkage. The label list is range 1 to 8, that is a figure size. So, when you run that, you are getting the dendrogram. Now, here what it shows that here we have entered k equal to 2, look at this value from sklearn. from sklearn.cluster import agglomerative clustering. When you put k equal to 2, we are going to say Euclidean distance and single linkage. So, when you what k equal to 2, so the cluster name is into two category, one is 0 is one group, one is another group. So, this was the labels 1, 0. So, when you run this, you see that there are two clustering. So, this is forms one cluster, this is form another cluster. Suppose if you write k equal to 3 here, you may get with 3 clusters. Now, I am going to the Python demo for doing this agglomerative hierarchical clustering. Now, I am going to show how to do agglomerative hierarchical clustering in Python. So, import this necessary library. I am running this. I have stored the data in the file name hierarchical underscore clustering. So, this is our data. For this, I am going to do this hierarchical clustering. So, first I am going to show the scatter plot. In that, it is showing all the objects. By looking at the object itself, you see that if you go for 2 clustering, that will be good. So, what we are going to do? We are going to do the single linkage. Here, I am going to show the figure size here also. Here, this picture, no, we are going to get the dendrogram. So, this is the dendrogram. So, 2 and 3 is forming one cluster, after that the 7 is joining, after that 6 is joining. Here at level 1 it is 1 and 4 is joining, then 5 is joining there, at the end is going to, all are going to be in the same cluster. Now, from sklearn cluster import agglomerative clustering, suppose we will start with 2. So, 2, so run this. Let us see hierarchical clustering, how we are doing. See that there are 2 clustering, it is one is named as 1, another one is 0. So, let us see what are the labels. So, this is labels 1 0 0 1 1 0 0. So, now if you run this, what you are getting? Now, there are 2 clusters. So, the red color points in one cluster, the purple is in another cluster. Suppose if you go for k equal to 3, let us see what kind of answer we are getting. Suppose if we go for k equal to 3, again you run it, you see that the level is 0 1 2, again you run it, level is, see that. Now, if you run this, you see that there are 3 clusters, green, purple and red. Because red is only one cluster, there is only one element. So, the optimal number of cluster for this kind of data set is k equal to 2. That is the purpose we can visualize how the cluster is formed and quality of cluster also. In this lecture, what I have done, I have started agglomerative hierarchical algorithm with the help of a numerical example. In that example, I found the distance matrix. After finding the distance matrix, I formed a cluster wherever there is a minimum value is there. I connected that 2 objects. Then I have updated the distance matrix. Again I have gone to where there is a minimum point is there. So, that point and that objects are clubbed together. At the end, for the same data set, I have explained how to do Python programming, and I also shown how the result is appearing. So, here the number of cluster I have initially started with the k equal to 2, then again I changed k equal to 3, but when I changed k equal to 3, I got some other result that is not looking good. So, I kept only k equal to 2 is the right number of clusters. So, optimal number of clusters.